Now we're ready to move on from the graphical and the addition and subtraction method to the solution by substitution. So again, we start with our relationships, our two equations, and we want to solve for x and y, but this time we're going to use a substitution method. So in this case, you'll notice that the first thing we did was we're going to take the first equation, x minus 2y equals 4, and we are going to put that equation in terms of x. How do we put it in terms of x? We move everything that isn't x from the left side to the right side. So now what we're saying is this solution for x is 4 plus 2 times y. So now we have an expression where we can solve one in terms of the other by doing a substitution. So we do that by placing the rewritten first equation that we put in terms of x into the second equation. So wherever we see x, we're going to replace it with 4 plus 2y. So now we take the second equation, 3x plus 2y equals 4. I'm going to substitute for x, 4 plus 2y, and now I'm going to multiply through and gather my terms. So 3 times 4 is 12, 3 times 2y is 6, so I have 6y, 2y equals 4. You'll notice now all of my x's are gone. I have this now in terms of y. So 12 will be moved to the other side of the equation, to the right side, and I will gather my terms 6y plus 2y, which gives me 8y is equal to a minus 8. Minus 12 plus 4 gives me minus 8. And we have a solution then of y equals minus 1. So now we can, again, to do a check here and solve for x. Substitute that minus 1 for y into either equation. We're going to put it in the first equation. So x minus 2y plus 4 gives me x minus 2 times minus 1 equals 4, and I get the same value of x equals 2. So the solution, x equals 2, y equals minus 1, is the same as we've seen before for the other two methods. Again, we can check this by inserting those values into the expression. Okay? So let's take a look at another example. Solve for the following. We have two expressions, two equations, 2x minus y equals 4, and x minus 2y equals minus 1. So we're going to rewrite the first equation in terms of x. So 2x minus y equals 4 gives me 2x equal to y plus 4. So I move the y to the right side of the equation. Now I'm going to divide through 2 on both sides, and I get x equals y plus 4 divided by 2. So once I have this solution for x, I'm going to substitute it in the second equation. So x minus 2y equals minus 1. I'm going to substitute for x, y plus 4 divided by 2. Minus 2y equals minus 1. So now if I multiply both sides of the equation, I'm going to lose the 2 in the denominator here. I end up with 4y equals minus 2. So 2 times that, 2 times that, 2 times that, they cancel out. So now all I have left are y's. So I'm going to gather my y terms. Minus 4y plus y gives me a minus 3y. And I'm going to move the 4 to the other side of the equation. It becomes negative, so minus 2 minus 4 gives me minus 6. And the solution is y equals 2. So now I can take that value, y equals 2, put it back in the first equation. 2x minus y equals 4. Substituting for y, I have 2x minus 2 now equals 4. Or 2x equals 6, 3x equals 3. So my solution that's common for those two expressions are x and 2. Okay, that was the substitution method. I'm going to stop here, and when we come back, we're going to come and look at something called a determinant, something that many of you may not have ever used before, and it's a rather mechanical and methodic method for solving for unknowns using the coefficient values for our solutions.